in this rule, you expand 1 over f of d into like this. In terms of d, you will expand after using binomial expansion, getting in terms of d square like that. Okay, binomial expansion up to the terms containing d power m, that is neglecting d power m plus 1, d power m plus 2, etc. and then operating each term on x power m. The following expansions are very useful. 1 minus x whole power minus 1. These expansions I have given already in Taylor series, common max 1 paper. 1 plus x square plus x cube plus so on. And 1 minus x whole power minus 2. 1 plus 2x plus 3x square plus 4x cube plus so on, etc. That is whole power minus 3 like that. So this is a difficult rule. Just you bring your 1 over f of d into whole power minus 1 like that, where first term is 1. If first term is not 1, you take out the term common term. That means not common term. You take out the constant term, then that position becomes 1. If no constant term in the denominator, that is f of d, then take out d term. That is d term with a symbol also. Then you will get plus 1 and send into numerator, which will becomes minus 1 or minus 2, then expand. I will show you the problem. See, for example, your denominator is like this. 1 by d square minus 3 into x cube. Okay, this is your f of d. X power m is equal to 3. So before expanding, before bringing into this numerator and then becomes minus 1, you have to get plus 1 into the denominator. That means you take out the constant term including symbol. So this is 1 over minus 3 into 1 minus d square by 3 into x cube, and then minus 1 by 3 send into numerator, 1 minus d square by 3 whole power minus 1 into x cube. Okay, so underline this term. It is in the form of 1 minus x whole power minus 1. What is the expansion? Minus 1 by 3, 1 plus, instead of x we are having d square by 3. Expand up to the terms containing d power m. Up to the terms, here m is equal to 3, up to the terms you expand. Up to the terms means d cube. The next term is d square by 3 whole square. Expand. Why I neglecting? Whenever derivative power more, higher order derivative, lower x degrees. Higher order derivatives, lower degree x terms always become 0. For example, take x square. Higher derivative, third derivative, fourth derivative of x square, how much? 0. So no use of writing extra terms, all terms. Okay, that is neglecting. Whenever the derivative order is more, comparing to x power, x degree, then that term becomes vanishes, zeros. Okay. into x cube. Operate each term on x cube. So operating means just multiplying. 1 into x cube plus second derivative of x cube. Before that 1 by 3 there. First derivative of x cube is 3x square and then next derivative is 6x. D power 4 derivatives of x cube. After that no use. Each becomes 0. That's why I given neglecting d power m plus 1, d power m plus 2, etc. Okay. Rule 4. 1 over f of d exponential ax plus b into v is equal to exponential ax plus b into 1 over f of d plus a into v. So here product of two functions where one is exponential ax plus b, other is we don't know v. Then write e power ax plus b into the preposition. D is replaced by d plus a. V is any function of x. Okay. So all rule 1, rule 2, rule 3 are single term rules. Now this is product of 2 terms, 3 terms, multiple term rules. Okay. Rule 5. 1 over f of d x into v. Here in the product one of the term is x, other is we don't know, that depending on the problem. In this x into 1 over f of d into v minus f dash d divided by f of d whole square into v, in both where v is any function of x. Generally x into sin x, x into cos x, this is useful. In this e power ax plus b into sin x, e power x into cos x, e power x into x square, that is useful, like that. This is the procedure. So please by heart all the above 5 rules. I am going to start the problems. One. Find the pi of y double dash plus 3y dash plus 2 times y is equal to 5 cos x. This is given 1996. Find the pi of d square plus 4 into y is equal to sin 2x minus 2 cos 3x. 3 sin 2x minus 2 cos 3x. First solution. So what is differential equation operator form? D square y double dash plus 3 into d plus 2 keeping y outside is equal to 5 cos x. So this is our capital X, right side of the given problem. This is left side after writing operator form denoted by f of t. So PA is equal to, what is the procedure I have given? 1 over f of d, that is 1 by d square plus 3d plus 2 into 5 times cos x. So when a constant is in multiplication, that is to a x term, this pi integration differentiation will not affect on that constant, multiplication constant. Okay, so bring into the preposition. So when a constant is multiplying x term, that rules will not affect on constant. Okay, keep outside, bring into the preposition. Now cos ax, comparing to rule 2, a is equal to 1. What is the procedure given? Adopted, put d square is equal to minus into a square. Minus into 1 square means minus 1. See, the denominator is 0 or not. Minus 1 plus 2 3d not equal to 0. 1 over minus 1 plus 3d plus 2 into cos x. By, just I am giving the reason, rule 2, your a value 1, d square value how much? Minus a square becomes minus 1. Here I kept that one. Okay. So this becomes 5 times 1 by 3d plus 1 into cos x. So where you stop this procedure? Until to reach the denominator is a non-zero constant or free of d terms. Here a one d term is there. How to eliminate? But this is a cos x. In rule 2, I gave the procedure d square is equal to only. I didn't put d is equal to something like that in rule 2. So to get d square in such type of problems, rationalize the denominator. What is rationalizing the denominator means? So for example, rationalizing factor a plus b. If a plus b is in the denominator, then you multiply a minus b in numerator and denominator. Similarly, if a minus b is in the denominator, then you multiply a plus b in numerator and denominator. So that denominator becomes a square minus b square. In such a way, you will be getting d square, and then again apply the procedure of rule 2, putting d square is equal to minus a square. So this becomes 5 times 3d minus 1. I am multiplying with numerator and denominator. So 3d plus 1 into 3d minus 1 into cos x. So this denominator now it is in the form of a plus b into a minus b, a square minus b square, in such a way that we got d square term. Again put d square is equal to minus a square. So this is 5 times 3d minus 1, 9 into minus 1 cos x. Just again I apply the above rule, rule 2, putting d square is equal to minus a square. So 5 by minus 10. So this simplifies to minus 1 upon 2, constant simplification. And the numerator, if any such d term, d square terms, don't apply the particular integral procedure. Particular integral procedure for denominator d terms. If any d terms in the numerator, just apply, multiply. That is using differentiation procedure. Just numerator d term numerator d square stands for differentiation on that x term. So 3 into derivative of cos x is minus sin x, minus 1 into cos x, no change. So this can be written as 3 by 2 sin x plus half times cos x. Next, see, second solution. Already operator form. Pi is equal to 1 by d square plus 4 into 3 sin x, 3 sin 2x minus 2 cos 3x. Now this is sum of two terms, sum or difference of two terms. Then that particular integral can be written as sum or difference of their particular integrals. Just operate this operator on each of the terms whenever it is sum or difference of x terms, keeping the constants outside. 3 into 1 by d square plus 4 sin 2x minus 2 into 1 by d square plus 4 cos 3x. Okay. So here a is equal to 2, by rule 2 put d square is equal to minus a square. So minus 4 plus 4 0. In rule 1 and rule 2, whenever denominator 0, then pre-multiply by x, go to the denominator and find its derivative. D square derivative 2d plus 4 derivative 0 into sin 2x minus 2 into, here a is equal to 3, minus a square becomes minus 9. Put d square is equal to minus 9. Minus 9 plus 4 minus 5, that is not equal to 0. Cos 3x. Since by rule 2 a value first case is 2 and second case is 3, and 1 by d stands for 3x by 2 integration sin 2x. Okay, minus plus 2 by 5 cos 3x. 1 by d I have given the notation, sin integration minus cos and then divide by 2 plus 2 by 5 cos 3x. Third one, 2011. The solution of the differential equation d square y by dx square plus 6 dy by dx plus 9y is equal to 9x plus 6. Now here the question is required solution. Now look at that, right side is 0, the solution is CF. Whenever right side not equal 0, you find both CF and PF, then add them, which gives the solution. Okay. So given equation operator form, d square plus 6d plus 9, keeping y outside, is equal to 9x plus 6. Auxiliary equation, m square plus 6m plus 9 is equal to 0. Factorizing, m plus 3 into m plus 3 equal to 0. Therefore, m is equal to minus 3 minus 3. That is, two roots are equal. Therefore, CF is equal to, comparing with fourth point in the table, CF table, m1 m1. C1 plus C2x into e power minus 3x. Next, particular integral. What is particular integral? 1 over f of d, that is d square 6d plus 9 into right side capital X, that is 9x plus 6. So this is your, comparing with standard form, that is x capital X, this is your f of capital D. Now, So 9x plus 6, sum of two terms. You can write this into 9x or this into 6, but 6 and 9x, all these are going to comparing with x power m is equal to positive integer. Okay, so that is I am comparing rule 3. I don't want to split, no use, unnecessary waste of time only. Okay, so I want to keep like that only. Okay, because if you separate you will get the same answer, but it is taking more number of steps also. Steps means simplifying purpose only. Okay, simplification takes a lot of time also. Okay, so in such cases keeping like that only. Whenever an x term with constant, don't separate. Okay, if a constant is with cos or sine or exponential rule 1 rule term, then you separate the terms. Just e power x or sin x or cos x plus any constant minus any constant, then you separate. In this rule 3, not required to separate. If you separate, you will get the same answer, but steps only just increasing. Okay. So in this is already perfect square. I can write 1 by d plus 3 whole square into 9x plus 6. To get plus 1, I have given standard expansions in rule 3, some useful binomial expansions. Which term to take out? Constant term. If no constant term, then d term. If no d term, then d square term take out. Then only you will be getting one of the position, one of the value in the denominator plus 1. Okay. So here I am taking the constant outside. 3 from square becomes 3 square. 1 plus d by 3 whole square into 9x plus 6. And this is 1 by 9, sending it to numerator. 1 plus d by 3 whole power minus 2 into 9x plus 6. It is in the form of 1 plus x whole power minus 2, second expansion, but I gave 1 minus x whole power minus 2. Just alternative symbols you substitute. Okay, in that is equal to 1 over 9. Just in your expansion what I gave, alternative symbols you put. Okay, 1 minus 2x, 2 into d by 3. So where do you write? That means up to which term you write? Where do you stop? Because the highest power of x is 1. Collect or write the terms up to the terms containing d power m is equal to 1. That means you collect up to the terms d power 1. Here we got d already, so and then not required to write other terms into 9x plus 6, and then operate each term on that x. 1 by 9 into 1 into that 9x plus 6 minus 2 by 3 into d of 9x plus 6. D stands for derivative with respect to x. 9x plus 6 derivative is 9, and etc. gives 0. So this simplifies to x. Therefore general solution is y is equal to cf plus pi. Just add these two. Next one is 2007 given. The solution of the differential equation k square d square y by dx square is equal to y minus y2 under the conditions. First condition is y is equal to y1 at x is equal to 0. Second condition, y is equal to y2 at x is equal to infinity. Y is equal to y2. K comma y1, y2 are all constants, comma is dash. Solution. So given equation operator form, all dependent variables are belongs to left side. This is not standard form. Bring y into this side. K square d square minus 1 into y. Now your right side is only single term minus y2, which is a constant. Bring this y into left side, then write in capital D notation, because I told you standard form is all dependent variable terms on left side, other terms on right side. Dependent variable and derivative terms. Comma d stands for d by dx. Auxiliary equation k square m square minus 1 is equal to 0. Solving, we will be getting minus 1 by k plus 1 by k. Therefore, CF is equal to C1 e power m1x plus C2 e power m2x. These are m1, m2. So, minus x by k plus C2 e power plus x by k. Next, particular integral 1 over k square d square minus 1 minus y2. So according the original notation, this is capital X and this is f of d. Now this is a constant. I didn't give the procedure for constant. So only if alone constant is there, then you write constant into e power 0x. E power 0x value 1, no change. Convert into rule 1 form. So just bring the constant into pre-position, and the remaining one I can write e power 0x. That means finally I made this term into rule 1 term. Here a is equal to 0. Okay. So what is rule 1? A is equal to 0, put d is equal to 0, the denominator not equal to 0. 1 over k square into 0 minus 1 e power 0x. Since by rule 1 comma a is equal to 0. Just compare your procedure, rule 1 given by me here in this problem. So this finally simplifies to minus y2. Now what is general solution? Therefore general solution is y is equal to CF plus PA. Implies y is equal to, add these two, C1 e power minus x by k plus C2 e power plus x by k plus y2. Equation 1. Now, see the second condition. First of all, I am simplifying. X is equal to infinity. This becomes e power minus infinity. This becomes e power plus infinity. E power minus infinity I gave 0 in the common max paper. E power plus infinity is infinity. So this is going to unbounded answer. So but we are seeing that bounded solution only. So this is going to infinity after putting x is equal to infinity. So in such cases, if possible, try to eliminate that term, so that after putting x is equal to infinity, that you will not get infinity. How to eliminate this term? Just multiply both sides by this term, because this is going to 0. Okay. So multiplying by e power minus x by k, comma, we get y into e power minus x by k is equal to c1 times e power minus 2x by k plus c2 plus y2 times e power minus x by k, equation 2. Okay, since e power minus infinity is 0, e power infinity infinity, substituting that conditions. If you substitute that second condition, here this is going to infinity, that's why I have done this step multiplying by other term. Now what are the conditions? Y is equal to y1, comma, x is equal to 0, and y is equal to y2, comma, x is equal to infinity, comma, 1 and 2 gives. Or directly 2 gives, substitute in 2. Because we multiplied, we got a new equation obtained from first equation, comma 2 gives. First, y is equal to y1, e power 0 value 1, c1 into e power 0 value 1 plus c2 plus y2 into e power 0 1. From this, c1 plus c2 is equal to y1 minus y2. Now, substitute the second condition, and y into e power minus infinity 0 is equal to c1 into e power minus infinity 0 plus c2 plus y2 into e power minus infinity 0. From this, c2 is equal to 0. Therefore, c1 is equal to y1 minus y2. c1 got, c2 got. Go back to your solution 1. Therefore, which gives the required solution. So therefore, 1 implies y is equal to c1, that is y1 minus y2 e power minus x by k, c2 0 plus y2 is the required solution satisfying the given conditions. So from this rule, from this problem what we observed here, whenever right side contains a constant k, then write k is equal to k into e power 0x, comparing with rule 1, and then apply the procedure. So this is given 2005 as above, you do later. For the equation x double dot t plus 3x dot t plus 2 times x of t is equal to 5, comma, the x of t approaches the following value as t tends to infinity, comma, is options A 3, B 5 by 2, C 17 by 2, D infinity. Answer is 5 by 2. Just I am writing hint. Equation is d square plus 3d plus 2 into x is equal to 5. So pi is you know CF. M is equal to minus 1 minus 2. Therefore CF. You know how to write. Pi is 1 over d square plus 3d plus 2, 5. Just now in previous problem I have given minus 5 to a constant. Here 5 is a constant. Can be written as bring 5 into the preposition. D square plus 3d plus 2 e power 0t, because t is independent variable. And you know how to apply. Okay. Later you simplify. And then finally apply t tends to infinity. After that, therefore, general solution is x is equal to CF plus Pi. Just write down as t tends to infinity, comma x is equal to, just apply, put t is equal to infinity after finding CF plus Pi, that is adding these two, and then put t is equal to infinity. Find the Pi of here we require only Pi. Pi is equal to 1 over d square minus d x square minus x. Don't split, even though it is sum of 3 terms, all the 3 terms belongs to rule 3 only, if I write x power 0 like that. Now here how to get plus 1, don't add and subtract. I have done this type of problem. Okay, there is no constant. So next term is preference is d term. Take this d term outside, including symbol, you will be getting plus 1. 1 over minus d into 1 minus d into, and this can be written as minus 1 over d times, send the remaining factor into the numerator, becomes binomial expansion 1 minus x whole power minus 1. That is. Now using binomial expansion, it is in the form of 1 minus x whole power minus 1 plus d square, up to where the power of x is highest power is 2. up to the terms containing d square. So here we can stop. But all these terms finally pre-multiplying by 1 over d. So if you multiply this term, you will be getting up to d power 1 only. So in this case, you need one more term plus d cube so on into x square minus x plus 4. Now send this 1 over d into the inside. Minus of 1 over d plus 1 plus d square, and you can put etc. because here we require term d square into since by rule 3. Now what is 1 over d stands for? This is nothing but integration. 1 over d stands for operate each term on x square minus x plus 4. So this simplifies to minus of integration of x square x cube by 3 minus x integration x square by 2 plus 4 integration constant into x. Next plus 1 into that term, that is x square minus x plus 4 plus derivative of this term 2x minus 1 plus d square, second derivative of that x square minus x plus 4, which gives 2, and then higher derivative becomes 0. Later you simplify. Next model is Cauchy-Euler type equation. Cauchy-Euler type equation. Just is similar to this previous chapter. The first lines, differential equation I given nth order linear differential equation, same the terms, a small change only. An equation of the form x power n times d power n by dx power n plus p1 into x power n minus 1 d power n minus 1 by dx power n minus 1 plus so on plus pn minus 2 into x square d square y by dx square plus pn minus 1 x into dy by dx plus pn into y is equal to capital X or q or f of x. Where p's p1 p2 so on pn are constants and capital X is a function of small x or maybe a constant, comma, is called a Cauchy-Euler equation or nth order homogeneous linear equation. Such equations can be reducible to linear differential equation with constant coefficients, comma, by putting z is equal to log x. In some textbooks this is given t, implies x is equal to e power z, full stop. Then if theta is equal to d by dz is equal to x d by dx, comma, we have x dy by dx is equal to theta into y, x square d square y by dx square is equal to theta into theta minus 1 into y, comma, x cube d cube y by dx cube is equal to theta, theta minus 1, theta minus 2 into y, and so on. Just see, compared to previous topic, linear differential equation with constant coefficient. N derivatives pre-multiplying by x power n. N minus 1 derivatives pre-multiplying by x power n minus 1. Second derivative pre-multiplying by x square. First derivative pre-multiplying by x. Here y means 0 derivatives, no pre-multiplying by x. That means every term in which order of the derivative is equal to the degree of x, the power of x, the pre-multiplication degree of x term. That is called homogeneous linear equation nth order. Homogeneity following. Okay. Now, this is also called Cauchy-Euler. Scientist invented this equation. Okay, where p's are constant as above. Then this is reducible to previous topic. What is previous topic? Linear differential equation with constant coefficients. That means again auxiliary equation CF/PI. What is the procedure? This is reducible to LDE with constant coefficients by putting the substitution z is equal to log x. Very, very important. From this, x is equal to e power z. In some textbooks, this z is denoted by t variable. Now, that is x is going to the another variable, third variable z. Your d square, d cube, d by dx, d square by dx square, they are going to d by dz. So, I am denoting a theta. Theta is nothing but operator, derivative operator. Theta is operator, derivative operator, differential operator with respect to z. Earlier it is with respect to x, d by dx problem. Now it is changing to z variable, third variable. So your derivatives are also changing into d by dz, d square by dz square. I denoted by theta. That in terms of old variable, this is x d by dx. So what is theta? It is a differential operator. It is not an angle. It is not a constant. In terms of x is x d by dx. In terms of z is d by dz. So with this substitution, from last term onwards, x into d by dx becomes theta into y. X square into d square by dx square is theta into theta minus 1y. Just theta reduces. Second derivative up to 1. Third derivative up to 2. And so on. In this way, your pre-multiplication x square, x cube eliminated with this substitution, and remember theta. Okay. See, here I am proving the first one. How do you get that theta? Since z is equal to how much? Log x. Therefore, dz by dx how much? log x derivative with respect to x 1 by x. Now dy by dx using chain rule in differentiation, this can be written as dy by dz into dz by dx. Okay, so therefore dy by dx is equal to dy by dz into dz by dx. I already found there. Bring x into the right side. Therefore x into dy by dx is equal to dy by dz. That dy by dz I already denoted by theta into y. So in that way x into I proved there. So please by heart the procedure. First, this is very important. More weightage also, that is equal weightage previous problems and this one, but less number of problems, because this is finally reduces to changes to becomes the previous topic again auxiliary equation CF PI only. Okay, observe the standard form is every derivative is pre-multiplied by the same x term, that is the power of x is equal to order of the derivative in each term, that is called Cauchy-Euler equation. What is the procedure? Put z is equal to log x, then x is equal to e power z. Then your capital D square, capital D cube in previous notation, now it changed to theta square, theta cube with this substitution. I proved there. But in some textbooks it is given again capital D notation only. But to avoid confusion between this topic and previous topic, that's why I denoted a new letter theta. Theta is not an angle, theta is a derivative with respect to z, theta is a differential operator. Okay.